Hi, I'm Ali, and today we're looking at phases of the moon. Humans have gazed at the moon for millennia and wondered. Bone artifacts discovered in France some 30,000 years ago have etchings on them, and they appear to indicate the 29-day lunar cycle. Representations of this lunar cycle have been found in cave paintings and carvings more than 20,000 years old. Observations of the moon gave early people a way to count the passage of days and to predict the arrival of the seasons. The oldest calendars were based on the lunar cycle. The gigantic stones forming the prehistoric monument Stonehenge, which was assembled some 4,500 years ago, appeared to form an astrological calendar, with some stones appearing to correspond to the position of the moon. Our modern calendar is primarily based on the solar year. If we look at the thematic analysis of the Australian Curriculum of Science, we'll see phases of the moon are specifically taught in the Earth and Space Science theme. The seeds for this topic are planted in Year 1 and Year 5, and they're developed more fully in Year 7, but they're also picked up again in Year 10. Your objectives for this video are to describe the relationship between the Earth and the moon, identify the CDSU for how the moon was formed, identify why the moon is vital to life on Earth, identify if the moon actually changes shape, and to describe why we see the different phases of the moon. The moon is the sole satellite of the Earth, and it's made of rock. It is held in its orbit by the Earth's gravity and goes around the Earth relatively quickly because it is close to the Earth. The moon is about a quarter of the size of the Earth, and its mass is much less than the mass of the Earth, so therefore the force of gravity is much less on the moon. The moon does not produce light. We see it from the Earth only because the moon reflects the light from the sun. The sun always illuminates half the moon's sphere. Phases of the moon occur in a regular pattern. If you chart the moon's position every night for a full month, you can compare its position with a bright star, and then wait to see how long it takes for the moon to come back to that position relative to that star. The answer would be 27 1/3 days. But during this time the Earth has moved itself, nearly 1/12 of its way around the orbit of the Sun, so to get from one full moon to the next would take about 2 days longer, 29 1/2 days, because the moon would have to travel a little bit further around the Earth to get to full again. The moon appears to change shape each month because we see different amounts of the illuminated surface of the moon at different times, due to the relationship between the position of the Earth, the Sun, and the moon at any particular time. Now, students interpret the world from their own point of reference as an observer on the surface of the Earth. Always remember to teach from the perspective of someone on the Earth looking out to space, rather than from space looking back down to Earth. When teaching this concept, one of the most important things is to watch the images, as most images promote alternative conceptions. Two-dimensional diagrams are often inadequate and can detract from learning, so make sure you use 3D models rather than two-dimensional models. Use movement-based teaching strategies for this concept. Use models, especially computer simulations, to help teach this concept. Ensure that students have observational, first-hand experiences of seeing the different phases of the moon.